So in this video we're just going to be taking a look at simple interest and compound interest. So we'll first of all be looking at some of the theory and the differences between simple and compound interest. So a lot of people tend to just memorize the formulas but don't really understand where the differences lie between simple and compound interest, and that's normally why they tend to get it wrong in an exam sort of scenario, because you're not understanding the mechanics that go on behind it and why the formulas are what they are. We're then going to look at some real life applications of simple and compound interest. So where are they used and where you might see them when you get into sort of working in the industry. And finally we'll look at just some basic examples of simple and compound interest. So first of all, just taking a look at some of the theory. Simple interest is when money is invested and interest is paid at the end of the period. So when you want to take the money out, the interest is then calculated in one lump sum. Whereas compound interest is where interest is paid at the end of each compounding period, and therefore you get in subsequent periods this interest on interest effect. So what happens is, in compound interest, if you're compounded monthly, you'll get interest at the end of each month, and then that then becomes your money. So if you had invested $100 and at the end of period 1 you'd have $110 if your interest rate was 10% per period. And then this would then build on the next time. Whereas in simple interest, it assumes that you don't have any of that interest. So your interest is calculated in one go. And without introducing the sort of formulas first, I just want to give a basic numerical sort of example of how both of them work. So if we're investing $200 for 2 years, what happens in simple interest is, I've used a formula, but it basically just works as at the end of 2 years, we just say we've had $200, 10% for 2 years, and we calculate our interest. Whereas in compound interest, if we compound it annually, at the end of the first year, we earn $20 interest, which would have been half of this. But this $20 then comes as part of our money. So the next period, we're on $22. And so in total, we've earned $42 interest. And that extra $2 comes from the fact that we've got 10% on this $20, which is the $2. So you can see here, because of the interest on interest effect, when you're compounding it, it's always going to be greater than if you just calculated at the end of the period. So just taking a look at the formulas then, we've first of all got simple interest formula, and interest is calculated as your principal or your amount that you invest times your rate and times your number of periods. Now in simple interest, it doesn't matter in what time units these are in, whether they be annual, quarterly, anything like that. It just matters that they're both in the same. So if your rate is per annum, you need to have n in number of years. If your rate is in per month, your n needs to be the amount of months that you've invested it for. Compound interest, however, the first important thing to note is that we calculate your total investment rather than your interest. So just watch out for that, whether they ask in a question for how much interest have you earned or what is the total of your investment, because you'll have to make adjustments to each of these for whatever the purpose is. Now with compound interest, it does matter what R and N are in. Now they do still have to be in the same time units, but the time units that they have to be in is the compounded time unit. And so if we have a 12% per annum compounded annually, R and N have to R has to be a per annum rate and N has to be the number of years. If we've got a 12% per annum compounded monthly, however, R has to be a per month rate, so we just divide it by 12, and N has to be the amount of months in the period that you've invested for. So applications, in reality, most things do use compound interest. So if you invest money in a bank or anything like that, you're going to be looking at compound interest. So it's really the one that we see most likely, especially because things like annuities or anything like that are based on this compound interest principle. However, there's one main exception to this, and that's with bank accepted bills. Now, bank accepted bills are short-term securities, basically risk-free securities, and you'll look at them in the risk topic, but they're very short-term securities and interest isn't paid on these securities. And so the bills are basically discounted to present time to reflect the time value of money without having to pay any interest. And how they're discounted is using simple interest because it's so short term. They're 180 days. So just looking at some examples now, we have $500 invested for 10 years at 4% per quarter. So looking at this in a simple interest, we simply just have, if we put R and N in both years, we'll have 16% per year, so 4 quarters, and 10 years, and so we get an interest of $600. So our total amount at the end of the 10 years will be $1,100, which was just $600 plus the $500 original. Looking at it in terms of a compound, so still $500 for 10 years, we've got 12% per annum compounded quarterly. So this needs to be converted into a quarterly rate. And I just realised that should be 3% there, not 4%, sorry. So it'll be 500, 1 plus 3%, 12% divided by 4 to the power of 40. And so that answer will be wrong, but it'll be whatever that should be. So that should be a 3% there. So that's basically it for simple and compound interest.